chart. So in this we draw individual chart as well as moving range chart. Now similarly, if the subgroup size, or you can say the lot size, is in between 1 to 10, it is greater than 1 but less than 10, then you should go for X bar and R chart. Here we have a mean and range chart. Similarly, if the subgroup size is more than 10, then we generally go for X bar and S chart. You can say mean and standard deviation chart. Because if the sample size is more than 10, then it's better to judge the variation in between the data points with the help of standard deviation rather than using the range parameter. So it will give less errorful decision. So that's why we use X bar S chart instead of X bar R chart if the subgroup size is more than 10. So these three types of charts, SPC charts, they are meant only for variable type data. Now if the data is in counts, like in defects or defectives, then you can say it's an attributable data. Then if you want to draw the defectives, then you have to see whether the lot size is constant or not. If you have a constant sample size or lot size, then you draw for NP chart. And if you do not have a constant lot size, then you go for P chart. Now similarly, if you want to plot defects, whether you talk about total defects or defects per unit, if the sample size is constant, then go for C chart. If you don't have a constant sample size, or you can say lot size, you can go for U chart. So this is the deciding criteria, you can say, we can use to draw which type of chart we should go for. So a defective unit can have more than one defect. Basically, if you go deeper into the attributable charts, then you can see in this particular matrix, we can draw P chart if you have a variable lot size and you want to draw a defectives. And if you want to draw defects for variable lot size, then you can draw U chart. So it's it gives more insight to the attributable type of charts. If the lot size is constant, then you can go for NP chart for defectives and C chart for defects. So subgroup size for attributable data is often 50 to 200. We have to take a huge data set in order to draw these attributable charts. So we have some slides further to draw these types of attributable charts. We are not considering the variable charts in this particular lecture, because generally we have seen attributable charts, they are ignored, but they are of equivalent importance in industry. So today's lecture is more or less focused on attributable charts. So we discuss one by one. Now this slide tells you the P chart. It tells you the formula. P stands for proportion basically. Proportion means proportion of defective pieces, and this is the formula for upper control limit, this is the formula for lower control limit, as these formulas are the function of N. N means sample size or lot size. So as the sample size or lot size varies, the upper and lower control limit will also fluctuates, moves up or down. So you can see, in order to make it more clear, you can take this as an example. Suppose you work in a plant that manufacture picture tubes of televisions. For each lot, you pull some number of tubes and do a visual inspection. If the tube has scratches on inside, then you reject it. So as the sample size varies, the upper control limit also fluctuates, lower control limit also fluctuates, because your limits are function of N, or you can say lot size. And you just draw the percentage, or you can say the proportion of defective pieces. Somewhere here at 6 point, you can see your chart is coming out of control. It's above, this point is above the upper control limit. The process goes, you can say, out of control here. The proportion of defective is more than the prescribed upper control limit, so we must take some corrective action to make the process well within control here. Now similarly, you can go for NP charts. These are the formulas for NP charts, generally drawn for constant lot size. So in order to make it more clear, we can take an example. Say you work in a toy manufacturing company and your job is to inspect number of defective bicycle tires. So you inspect 200 samples. Here the sample size is high. As I have said, for every attributable chart, we have a huge sample size as compared to variable chart. So in each lot, then decide to create an NP chart to monitor the number of defectives. Here you plot number of defectives directly. Okay. Earlier you draw, you are plotting proportion of, or you can say percentage of defectives. So this is the main difference between P and NP chart. Similarly, you can go for defects. If you want to plot defects, process defects, then you should go for C chart. Say the center line formula is given, the total number of defects divided by total number of subgroups. Means per subgroup you calculate number of defects. This is the formula for upper and lower control limit, and it is independent of lot size, you can see. So if you know these formulas, you can easily plot the diagram, this C chart. This is the example that I have taken. Suppose you work for a linen manufacturer, now each 100 square yard of the fabric can contain a certain number of blemishes or maybe a defects before it is rejected. Now for quality purpose, you want to track the number of blemishes per 100 square yards over a period of several days. Now to see if your process is behaving predictably or whether it's stable or not, you should go for drawing C charts. You just apply, calculate the upper and lower control limit, calculate the mean line, and then try to draw these number of defects over here. If they are within control limit, then you can say process is quite stable for, you can say, a period of time. Now if you want to draw control charts, you can say for number of defects per unit, means per unit how many defects you have, you want to discuss. Then this is the formula for center line, this is the formula for upper and lower control limit. Now you can say here again, upper and lower control limit is a function of n. You can say that if you varies the sample size, the upper and lower control limit will get varied. So in order to make it more clear, let's take an example. Now as the production manager of the toy manufacturing company, you want to monitor the number of defects per unit of motorized toy cars. Now you inspect 20 units of toys and created a U chart to examine the number of defects in each unit of toy. Means we have taken a sample of 20 toy cars and we just calculated how many defects you have per unit car. Means for each car how many defects it has. That's so here if the defects are more than upper limit, you can say you have to reject these pieces, and otherwise they are well within control. So in this way you can draw number of defects per unit and see whether the process is in control or not. So for further query you can contact me at dr_bikramjit@mmumullana.org. Thank you very much for your patience. Thanks.